Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So I'm going to talk about how to find area bounded by a chord or area of a segment, okay? Please, it's very important you watch the previous video because they are key to understanding this topic. All right, so before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. So in the beginning of the series, I've introduced some terms. I talked about the major segment, the minor segment. I talked about the chord. I talked about the radius, the sector, the minor sector, and the major sector, okay? So I'm going to just do a quick reminder here about that so that because I need these concepts in order for me to explain what I want to do. So if you have a circle, okay, let's assume there's a circle, and you have a line going through this. Now, if this is the center, so far you have any line going through the circumference from one point of the circumference to another point. This is what we call a chord. Okay. Now, the bigger part, okay, is what we call the major segment. And the smaller part is what we call the minor what? Segment. Okay. Now, also, I also talked about in a circle. If you then have the center of a circle, but the line is going through the center, I told you that this is what we call a diameter. Okay, and the other part is what we call the semicircle. Okay, and also I also explained, but if you have any line moving from the from a circle, okay, this is just a reminder to the circumference. This is what we call a radius. Okay, so a radius basically is half of a what? Of a diameter. All right, so that is that. So another thing again I talked about is that when we have so we can form an arc that you can get an arc that has two radii of a circle, and the length of an arc will form a sector. So that means basically an arc, okay, an arc and two radii. Talked about this earlier, so I'm just doing a reminder. So two radii of a circle will form a what? Sector. So that means if we have a circle, so we've already established that we have this, which is the radius, this, which is also the radius, okay? Now, let's assume this is the center A, then this is A and B, all right? So if we look at this one, okay? So the one I shaded like this, okay? This is gonna be the minor sector. And the one that is blank, okay, is the what? The major what? Sector. So the minor sector, so you can call it OAB, all right? And the major sector, OAB as well. Now, another thing again I told you as well is that every sector, so for the minor sector, the angle here is going to be called theta. Are you seeing it? While for the major sector, the angle here, we can call it alpha. So for the major sector, the angle is alpha, while for the minor sector, the angle is what? Theta. So if you want to break this down, you can break it that you can have particular sector like this. Okay, so you have here to be theta, and this is the R, this is for the minor, okay? Or you can have it to be like this. Okay. And this is what? Alpha. And this is R and R. And this is for the major what? The major sector. So you can look at it in different ways. All right. So now this is not where we're going. All right. We're trying to get to, just follow me. I'm trying to get somewhere. So now we've known the sector. Also, I also told you now that if you now have two radii and a chord, now together they'll form a triangle. So basically what I'm saying now, so that if we have these two radii, okay, we already have the radius here. So these two radii and the chord, so now this time we have the radii and the chord of the segment together form a triangle. Okay, so that means if we go back to this, so we've established that if you have a circle, okay, then we said this is the radius. So we have R and R. Now, but if we have a chord now, so this is a chord. Remember I talked about a chord? Now you can see at the middle here, you have a triangle. So you can see you have a triangle OAB. Can you see? As well as the sector OAB. So you have a triangle now. So now how do you now find, you now notice that at the end of the day, we have a segment here. This part here is what we call a segment. So the place I shaded is equal to a what? A segment. So how do you find the area of this segment now? Now, if you look at this, so you can see it's a combination of two things. We have the sector and a triangle, all right? We have a sector and a triangle. So the area of the segment of the circle is obtained by subtracting the triangle from the area of the sector, all right? So thus, we can now write it down. The area of a segment of a circle is obtained by subtracting the area of a triangle from the area of the sector. So what I'm saying, if you need to now get this shaded area, so you have to first get the area of the total sector. So remember, I told you that the sector is all this part here. So all this here is going to give you is the area of the sector, okay? So if it's a major sector, all this part is going to be the what? The major sector. Are you seeing it? So now using the minor sector as an example here. So to get the area now, what you have to do is that you have to then, the red part, which is that, the total area of the sector. So the sector here is the total red part here. Are you seeing it? So the whole red part minus the area of the triangle. So if you want to see the triangle, you can see that the triangle we have here. So to get the triangle only is going to be this one here. So this is the triangle part only. So that means if we get the area of the sector minus the area of the triangle, it's going to give us the area of the what? The segment. So I can then write this down. So the area of segment is equal to the area of sector okay, minus the area of triangle. So if you want to look at this now, if you want to put it in light of this one we have here, so you can say area of sector OAB. So the sector is OAB minus area of triangle OAB. So that's how you get the area of what? Area of segment. The area of triangle minus the area of what? Area of sector. So sorry, you take away the area of triangle from the area of what? Sector. All right, so we then have to now derive the formula for this, okay? Since we know that the area of segment is equal to the area of sector minus area of triangle, so there are things that you need to keep in mind, okay? Now, the angle subtended by the sector could be in degrees or radians. So that means this theta here, okay, the theta we have here could be in degrees or radian. So now if the theta is in degrees, okay, so if theta is in degrees, so let's start with the first one. So when we have theta in degrees, okay, so if the theta is in degrees, the area of segment, we know that the area of segment is equal to the what? The area of sector minus area of triangle. So I've talked about area of sector and area of triangle in the previous series, so please go back and have a look. So, but if it's in degrees, I told you that the formula is theta over 360 times pi r squared, okay, minus the area of a triangle is 1 over 2 r squared sine what? Theta. And that's the formula. Now, some of you might want to simplify, okay? Some of you might want to simplify this. Now, if you want to simplify this, you can take r squared out, okay? So you can have r squared, and then you have theta pi over 360. Then common factor there is also r squared, so it'll be minus sine theta over 2. So this is how you find the area of a chord. So you can either use this if the theta is in degrees, okay? Now, but if the theta is in radian, so you have to use another different formula for this. So it's the same thing, it's just that the formula you're going to use for theta is going to be a bit different. So we've dealt this before. All right. So number 2. So now if theta is in radians, okay? So if theta is in radians, so the same thing, the area of a segment we equal to area of sector minus area of triangle. So I told you the area of sector when it's in radian is what? 1 over 2 r squared theta. Are you seeing it? Now when it's in radian, the same formula is going to be 1 over 2 r squared sine theta. So if you want to simplify, similarly, r squared is common, and then it's going to be 1 over 2 theta minus 1 over 2. Oh, yeah, 1 over 2 is still common as well, so I can take 1 over 2 out as well. So I can say r squared divided by 2 because it's still common. And we now have theta minus what's common here, sine theta. So you can use this to solve. So when you have it in radians, okay, when you have it in radians, you use this formula because the area of a sector in radians is different. And when you have it in degrees, you use this formula here. All right. So let's pick some examples now and solve. So we have this. So let's pick an example. So number one, we're told to find the area of the shaded segments in each of the following sector. Or in the sector in the figure below. So we have something like this. So we're told this part was 60 degrees and this part was what? 10 centimeter. Then we have this. So we're told to find the area of that shaded region, okay? So as you can see in this example, the angle here, it was given in degrees. So we then have to use the formula with degrees, all right? So let's go. So we have the area of segment is equal to area of sector minus area of triangle. So this is going to give you area of sector is theta divided by 360 times pi r squared minus area of triangle is 1 over 2 r squared sine what? Sine theta. So this is going to give us our theta. Here was 60 divided by 360 multiplied by pi 10 squared minus 1 over 2 10 squared sine 60 degrees. Are you seeing it? Now, when you press this in your calculator now, so to get the answer, so for the first one, it's going to give us 50 over 3 pi minus 25 root 3. Now, when you put this in your calculator, you're going to get 9.06 centimeter what? Squared. So this will be equal to the area of what? The area of what? Segment. All right, it's got. All right, so I'm going to just add one more example, then I'll call it a day for this. So number 2, we're told to find the area okay, of the shaded segment in each of the follow in the figure below. So we had this. Okay. We told this was 1.05, and we have this to be 5 what? Centimeter. All right. And we're told to find the area of this part. Now, one thing I need you to know is that if you look at this angle, you can see it looks like a small C. So anytime you're given a question, all right, something I need you to note, okay? Anytime you're given a question and you see that you had either something like small c, you have something like small c, or you had pi, so you should know that that question is asking you what? For radian. Is that making sense? So that means the question is asking you for radian. So that means if you see something like c, or you see a superscript c, or you see an angle given in pi, it means that that angle is in what? It's in radian. So please don't forget this. It's very important. So as you can see in this example, this was 1.05. It has a superscript c. It means that the angle was given in radian, and therefore we have to work with what? With radian. All right, so let's go. So now the next thing is that we now do the area of a segment. Is equal to area of sector minus area of triangle. Okay, and I told you that the area of sector for radian is 1/2 r squared theta minus area of triangle. We know that to be 1/2 r squared sine what? Theta. So in this example, we can see that our radius here was 5, so it's going to be 5 squared. Then our theta was what? 1.05, so in radian, right? So it's very important at this stage now that if you have a calculator, you need to convert your change the calculator settings, all right, to radian. So every different calculators have different ways to do that, all right? So you have to change it. And it's going to give us, we have 1/2. R is 5 squared. Sine, our angle there is now 1.05. So it is what? In radian. So now when you go to your calculator, you punch this into your calculator. The first one is going to give you 105/8 minus the second one is going to give you 10.84. And when you do this together, it's going to give you 2.285 centimeter what? Squared. So this is going to be the what? The area of segment. So that means for that, the area of segment is going to be equal to 2.285 centimeters squared. All right, and that will be that for that. Okay, please go to the worksheet, go to the textbook, solve more questions. And if you have anyone that you're struggling with, please bring it to me or send me an email and I'll get back to you. All right. All right, thank you very much. So I'm going to see you in the next video where we're going to talk about more interesting topics, as well as we're going to start new series as well. See you and have a nice day. See you soon.